Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 13th, 2025, just 3 days ago. It shows that a compact diffusion transformer with only about 140 million parameters can reach FID 3.49 and KDD 0.319 on ImageNet 256 in just 400,000 training steps, matching the image quality of models almost 5 times larger that train much longer. The paper is titled Speedrunning ImageNet Diffusion, and as we will see later, the efficiency gains for training image generators are pretty remarkable. Alright, Figure 1 gives a visual sense of what this compact diffusion transformer can do at 512 pixel resolution. The grid shows diverse ImageNet-style samples, including birds, mammals, insects, and indoor scenes, which all look sharp and coherent. Several objects such as vehicles, musical instruments, fruit, and food also appear with realistic lighting and textures. The bottom row includes more challenging scenes like underwater coral and a swimming shark, so the range of subjects suggests that the model generalizes broadly across categories. Figure 1 showed what the samples look like. Table 1 now quantifies how efficiently the compact model reaches that quality. The top block lists SITB2 baselines, where even with representation alignment, the FID stays around 15 and KDD is not reported. The lower block adds components step by step, and every row tightens FID and kernel DINO distance. With all tricks enabled, the 140 million parameter model reaches FID about 3.5, kernel DINO distance 0.32, and an inception score above 220, which rivals much larger diffusion transformers. Alright, Table 1 described the end result at 400,000 steps, and Figure 2 shows how fast each method gets there. The original SITB2 baseline starts with very high FID, and only crawls down toward the mid-30s. Adding REPA and then REG steadily lowers the curve, so convergence improves. The SR-DiT-B1 curve drops fastest, going from roughly 21 to about 3.5 FID by 400,000 iterations, which means the compact model reaches high quality with far fewer training steps. So Figure 2 focused on training speed, and Table 2 turns to absolute performance at 512 pixel resolution. The table compares the compact SR-DiT-B1 model against much larger DiT-XL 2-star and UDITB baselines. Across the board, SR-DiT-B1 posts the best Fréchet inception distance, spatial Fréchet inception distance, and kernel DINO distance, meaning the samples are both sharp and semantically accurate. The compact model also reaches a huge inception score near 190 and the highest precision, so it delivers stronger ImageNet 512 quality despite using far fewer parameters and training time. Alright, Table 2 compared scores at 512 pixels, and Figure 3 now makes the difference visually clear at 256 pixels. The top row shows images from the REG plus IN versus AE baseline, which already looks reasonable but still has softer textures and some odd shapes. The bottom row from SR-DiT-B1 produces crisper car details, more realistic dog fur, cleaner sweaters, and sharper iguana scales. Human faces and the orangutan also look more consistent and less distorted, so the upgraded architecture clearly improves semantic fidelity. Well, Figure 3 emphasized visual quality, and Table 3 now tracks how that quality evolves during training on ImageNet 256. The top block with SITB2 baselines stays relatively weak, with FID still around 15 even after 400,000 steps. The lower block shows SR-DiT-B1 rapidly improving, cutting FID from about 22 at 50,000 to 3.5 at 400,000. Inception score more than triples, and kernel DINO distance falls sharply, so the compact model gets both sharper and more semantically accurate as training proceeds. So the big takeaway is that a carefully tuned, 140 million parameter diffusion transformer can match or beat models several times larger and do it in a fraction of the training time. That kind of efficiency really lowers the barrier for high-quality image generation research. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.